In this screencast, we'll demonstrate the use of Micro-Magellan's covariant pairings feature. In particular, we'll show how this feature can be used to set up gradients of excitation light intensity based on the position of the focus drive. We began by having explored the first 120 microns below the surface of a tumor in intravital microscopy. We conducted this exploration with a constant amount of laser excitation, and as you can see, as we go deeper, the signal falls off dramatically. First, we'll create a 2x2 grid to image using a standard Z-stack. Next, we click on the plus button to create a new covariant pair. The independent covariant in this pair will be the Z position of our focus drive. The dependent covariant will be the excitation laser power. We will now create several paired values. Each one will have a given position on the Z-axis and a given laser power. For each Z value we choose, we'll navigate to the focal plane in question and empirically choose the laser power so that our signal stays constant throughout the Z-stack. After updating the laser power in the device control panel, we'll continue re-imaging the same region. We will repeat this process until we find sufficient brightness in our image. After that, we can enter the value of laser power that we used to collect it into the covariant pairing list. We now repeat this process at several different values of Z. After generating several pairs of data for this covariant pairing, we're ready to use it to run an acquisition. During this acquisition, before each image is collected, Micro-Magellan will check the current position of the focus drive. It will then calculate and set an appropriate amount of laser power, based on a linear interpolation of the data points we supplied. As the acquisition runs, we can see that we've now achieved approximately constant signal strength through the Z-stack. The difference in image quality can be clearly seen.